Hello and welcome to the second episode of 5 Days of Pandas for Beginners. In the first episode, we took a look at this dataset of Messi versus Ronaldo statistics, and we realized who has scored the most goals. So here you can see we imported Pandas, we read the CSV, and we applied these methods. We checked the first rows, the last rows, and some information, again the number of rows and columns, data types, and some statistical operations on the rows and the columns. Then we also selected only these three columns, that is the goals and the players. And then we selected only the Messi and Ronaldo rows. So by these conditions, we checked if the value under player equals Messi, then put it inside this data frame. If it's Ronaldo, put it inside this data frame. And then we summed up the values under La Liga goals and also Champions League goals. And we got this information about Messi and Ronaldo. Then we filtered again the data to see the goals above 40 in a season. And we got this one. But not all datasets are as clean as this one. And by clean, I mean all the cells have values in them, and the values are in a good format. That is, all of these, for example, are integers. All of these are integers. These are all text. So they are in a good format. But most of the time, the dataset you receive includes some missing values or some wrong numbers. For instance, if all of a sudden you see here, instead of 43, you see 430, you will doubt if that is the correct number. Because, come on, 430 goals, that's far above realistic. So even for Messi. So you need to account for those mistakes. Now, this is what we're going to do today. I have generated like some random information by using randat.com. You can choose the first name and all these, 100 rows, and choose a CSV file, generate, and save it. I've also added my own. I have deleted some of these numbers just to make sure we learn how to clean data. Now, I have included here. I will also include it in my GitHub repository so you can access this as well and follow along with me. Now, let's import Pandas as PD, an alias. Let's run this or Shift Enter. Then we are going to read the CSV that I just talked about and save it inside the Pandas data frame. We can check the first 5 rows to see what we're dealing with. We have these, okay, everything seems fine. Oh, okay, except date of birth, 81 here, and 1976. So we need to clean that up, and some others. Okay, not very big. Not a big issue. Now we can check for some technical information, an overview of what we're dealing with. We have 100 rows and 9 columns. These are the names of the columns, okay. And how many out of 100 are full or empty? Here we see 100 non-null. That is, there is no missing information here. Except for age. Under age column, we have apparently 3 null values. That is 3 empty or missing, let's say, values. And you can see also the data types here. Integer for IDs, okay. Then we have age as float. Age should normally be integer. Then date of birth is object, and object we said is like string, but we can change or convert the date of birth to a date time data type. Okay. Now the first thing I want to do is to actually, let me show you, to set this ID column as my index. Instead of 0, 1, 2, 3, I want to have a label. I want to set this column as ID. But we should check if all of these IDs are indeed unique. Is there any 1000 somewhere else? If that is the case, it's not that nice to have the same ID for 2 or 3 people. So I can check by this here, df ID, there is a column, is unique if all the values are unique and is true. If I had some duplicates, it would say false. So it's good to be an index. Now, the next thing I do is I say my df is going to be now have a set index ID, and ID is the name of that column. So by this method, I'm going to set the index of my data frame with ID. And now let's check the df.head now. And let's see what's happening here. None of ID are in the columns. Okay, so this is what's been happening. Let me read this here, do this here, because I had to do it like this one by one. And now it's good. Okay, so now we see that instead of 0, 1, 2, 3, we have ID as the index. Perfect. Now let's check the missing values. One way to check the missing values is by using is_null, or not a number, or is_null. Both are kind of the same in Pandas, or is_null method. And that returns true or false. So it would show us all false here means that there is no missing value, there is no null. Well, at least what we can see. But I want to sum, to give me a sum of the null values there are, and I can't see them. So I use .sum, and look at this. First name, no null. But we have 3 missing values there. So we need to deal with them. I want to see which rows there are. So to check the rows containing those missing values, I'm going to use the filter that we learned about in the first episode. We use the data frame, and inside that we check for true or false. df.age, that is go inside that column, and if it is null, it means it's true, and give me all the true values, not false ones. So now if I run this, I get the 3 rows which they have age as nan, not a number, that is missing. So now I know these are the rows where I have some issues with. What am I going to do with them now? So if age is really important in this data set, and if I really need to have some numbers to do something with them, then I can't just delete them. But maybe it is so important that I need to have a real age of the people. So I can't just ignore this. Maybe I need to delete these 3 rows that include missing values, or all for that matter. So to drop all the rows that include or contain missing values, we use a drop now method. So now I'm going to say df1, because I don't want to delete the original file, affect the original file. I'm creating a new data frame, and I say that data frame is going to be the old data frame, and drop the missing values, the rows with missing values, and save that inside df1. Now, what is the information on df1 now? Let's see. Instead of 100 rows, now we have 97 rows. You see, now all are full. Good. Or maybe not good. It depends on how you want your information to be. So if you're okay with this, you don't mind leaving or dropping 3 rows because of these missing values, then go for it. But sometimes you don't want to do that. You rather keep these and fill the missing information with something else. Maybe, I don't know, with something like 20 or 30 or 40, or even the average of all numbers. What do I mean by that? Well, we are still dealing with the df, that is the old one with these missing values. So I can say df_age from now on is equal to df_age dot fillna, that is fill the missing values, and fill the missing values with what? You can say 30. Then here you would see 30. But this is so random maybe. Maybe I can say, okay, fill them with the mean the average of the whole of all the ages inside that column. So now if I shift enter, if I run this, and now if I check this again, do I see any missing values? No. 100 entries and age 100, right? So now we have filled these gaps with the mean or the average. But what is the average, by the way? So let's just check it now. Actually, I can check it. Let me copy this. Let's check it down below. Here it is the average, 23.5 almost. That's why it's a float, right? Data type. But for age, we normally say 23 or 24, 25. We need integers. So that is something we need to change. And I think I've changed it somewhere else. Yeah. So let's change it now. Actually, where is it? Yeah, here. I'm going to move this up here. Okay. Now we are going to change the values, data type of age from float to integer. In Pandas, the way you do it is you create a new variable again, and then you say this new age is going to be the old column as type int. So as type is a method to change, to convert data types into something else. Now if I run this by shift enter, and if I check the df age dot d type to check the data type of this, you see it's now integer. Yes, perfect. So it is integer now. Now another thing that we need is date of birth from an object data type to a datetime data type. It's much more neat and more nicely formatted now. So let's do it by this method. For that, we don't use as type. For datetime, this is the usual one. So this column, this series, is going to be using Pandas to datetime method and apply that method to this column, date of birth, and then save these changes to this date of birth. And then let's run this, and now that I've run this one, I can see the differences here. You can see now I have this. Date of birth is datetime now. Now let's see the difference. It's really interesting. So if I run df.head, and if I run this, look at this. This is much better. Looks much nicer as well. It also gives us access to do a lot of other things later. I will show you why it's important to do this. Okay. Now we have another column called gender. I want to check and count the different values in that series. I want to see how many gender types are there in that column. So I use .value underscore counts to give me the counts of different values. I can see female, we have 50, and male, we have 49, and we have mile, which is 1. This is weird. I think mile is this misspelling of male. That is why we need to replace this mile with male. So to replace it, we use the Pandas replace method. So again, df gender equals df gender, that column, dot replace. So we are going to replace mile inside that column. If there is a mile, replace it with male. And let's run this. And now if I run it again, you see I have 50 male, 50 female. All equal, equality now. So, and now another thing that I can do, because I can see these are categories. It's not like a lot of them, just 2 of them here. So I can use another data type, which is called category in Pandas. So let's also change this column, this series, gender as type category. Let's change it into the category data type. And now if I run this data type, you see it's categorical data type. And I can also check with another df.info to see what's happened here. You see that now we have a category here. And 6.5 here, let's see if there is a change in the memory, and 7 here, you see. So by changing these data types, it's easier for Pandas to process them, and it uses now less RAM. So that is better. Okay. Now another scenario is that I want to drop some columns that I don't need. Maybe I have, I don't know, tens of columns. I want to drop a lot of them. I don't need them. So to drop your columns, you can use this drop method. So df from now on equals, or you can even use a, I don't know, a new data frame. But df equals the old df, drop, and columns equal, inside square brackets, we have education, occupation. I don't need these two columns, so I just drop them. And now if I take a look at dot columns to see the columns, you see we have these. There is no occupation or education there. And if I check the head, the first two rows, you see that is how it is. Okay, now how can I locate or some information about a certain ID? For example, your manager comes to you and says, hey, I want the information on the person with ID 1005. How do I do that? Well, to locate rows with labeled IDs with IDs, what we do is we use lock for locate. Now here, if someone wants 1005, the person with this ID, the information on this person, df.lock 1005, and if I shift enter, I get the first name, last name, gender, age, salary, and date of birth. If I want the information from the person with the ID of 1005 to the person with the ID of 1010, this is just like the Pythonic way of doing it, right? With these columns. Now, if I do that, you see from 1005 to 1010. Remember, this is not like an index for lists, because in lists, it would be from this number up to, but not including it. But with lock method, because these are labels, they could easily be also names. It could be something like, I don't know, name to the row, something, whatever. So they can even be strings. That is what lock does. So it works based on the labels. Now another method is using ilock. If you don't know the ID and you want to have, I don't know, someone at the row 6th or 7th, for example, you use ilock for integer. So if I say something like 5, df.ilock 5, it starts from 0, 1, 2, 3, 4, 5. Gives me the 6th person in that list, and this is it. You see Fenton again. So Fenton is at this 1005. It starts at that. So let's just see it again here. So now you see we have 1000, 1, 2, 3, 4, 5, 6, right? It's at the index 5. Fenton, and here we have it. We can do the same thing from that index 2, but not including 10. That is 5, 6, 7, 8, 9. So this is what ilock does. Now we can also use another thing. For example, I want to know exactly the person with the ID of 1007, what is their salary. So I want a specific value. So we can use @ we can also use lock here as well, but @ is specifically for this. So df.at inside square brackets, I would say 1007, for example, let's choose 1007, and give me the salary under salary. The spelling should be correct. Now it should give me the same 7,840, and you can see it here and here. I can do the same thing with up to 11, but not with at, because if I run it, you see there is something wrong. I need at only gives me one of them. So for this, I need to use lock now. If I use lock, you see I have the salaries of these people with these IDs. So we have learned a lot, and it's been 20 minutes so far. That is what we have been doing. Well, that's what we have for now, for today. And I just encourage you to go download this CSV file that I have created here. Try to do the same things that I did. Come up with some information. Maybe if you want to use what we did also in the first episode, try to do those as well. I have included the link in my GitHub repository. Please don't forget to leave a like or share. And thank you very much for watching and listening.